Good morning, good afternoon, everyone. Thank you for joining another session in the Azure community. So today we will be discussing about automated assignment scoring via OpenAI services, ChatGPT, and today we have Marcus and Wang Chun, who is MVP, and Marcus is a student at data center administration, and he is both of them are going to help us better understand on how you can use OpenAI and using to do the automated assignment scoring for educators. So before we get into the session, I just want to share that the session is recorded and will be shared in our YouTube channel, and there is certificate of participation to those who stay till the end. So that's basically two things that you should know. And if you have any questions during the session, please do drop it in the chat box, and we'll take it in between or at the end of the session. And that's basically it from my side. And over to both of Marcus and Wong to get started.
Okay, thank you. Hello, everyone. I'm Cyrus from Hong Kong, and my student Marcus, and we are happy to be here to be able to share our work and about the large language model application today. And just first introduction myself. I'm the senior lecturer of in a technical institution of Hong Kong. This under government is so-called Hong Kong Institution of Information Technology, and literally Hong Kong IIT. And then I run a full-time program, high diploma in Hong Kong. I am a program leader, and it means I manage the course and also recruit students. And beside the AWS, Microsoft MVP, I am also a Google developer expert in Google Cloud Platform, and also the AWS Machine Learning Hero from Hong Kong. I'm the unique person of three major cloud vendor honor. Before the event start, I have something promotion to international. For this year, Hong Kong have a special policy support about the international student can come to Hong Kong to study the full-time course and then get the qualification and then stay at Hong Kong for their full-time job. It's so-called professional, vocational professional administration scheme, VPAS. And and my courses is one of the courses. If you want to learn about cloud computing, especially in multi-cloud render, my course is one of the candidate courses. When any student graduate from my course, it's a so-called high diploma, not a degree program. The entry requirement is low. You can take up the 2-year pilot course. We are under the information technology. Then after 2 years study, you can stay at Hong Kong to get the working visa without any special or additional requirement for you. And this is the flow of the VPAT program is high diploma and then stay in Hong Kong for 3 years and then you can get a job and then continue to stay at Hong Kong without any special condition. Okay, now is let me go back into my talk. First of all, I have AI will not replacing you, but a person using AI will be. Yeah, this is there's a statement about this in internet. I copy from a guy from X from Twitter, and this the truth of that is that if you are not using AI, something like the story of calculator, in the past you there's no calculator, that you everything do it by hand. But someday a calculator is here. If you don't using it, then you will be replaced by someone in the future. And for this first session, I will present, and then the next session will be by Marcus on the project. First of all, what is large language model (LLM)? And typically, we will talk about large language model is a type of AI model that can understand and generate human language in different languages. Don't just matter, just something a human able to write the natural language themselves, Chinese, English, whatever language, and then reply you through the language. Um, and the second one is that this is a very so-called large language is using like nearly all of the realm of all of the data in the realm is the text format, and then it's just train the machine learning model, neural network model, which fools a lot of data so that it's able to do different kind of job, as the language is imply all the logic or in the realm, so it understand everything. And large language model is this. not just for a single task. Since the data they learn from the route is everywhere, all data all the route, everything, it can able to do any task you like. You just give him a instruction, and then it will try to help you to finish the task. And it's still under the very heavily under development. It's changing all the time. Sometimes it's, that in the past it's just ChatGPT. Now we got Gemini Pro, OpenAI, and a lot of changes all every day. And today we will discuss about the large language model application. But in general, from the public, they just a lot of people just think about the large language model of OpenAI, ChatGPT, or something. It's just something like a chatbot. A chatbot, just you put the question there, he try to answer give you an answer, something that say people say, something like Google. No, no, no. Actually, behind the scene is that large language model is not just for answer your question. Well, most of the people just understand the semantic completion side. This is, I mean, the autocomplete. Behind the scene, actually, when we're training, they are doing the autocomplete, not answer your question. But due to the autocomplete on the question is the answer, so the LLM answer your question. This is something look like answer your question, but actually it's autocomplete. So-called it's a semantic completion. Another sign is semantic similarity, and a lot of non-technical guy is omit that this feature is very very important, and then we will use this today to solve a problem. And what is the meaning of similarity and semantic similarity? Is that we will try to train the language or whatever language, English, Chinese, Japanese, whatever. Just on top of the language, there are difference, but maybe the meaning is the same. We will just try to use a large ranking model to convert the text according to the meaning, not the language on the surface, become a writer. And then become a writer, we can do a lot of writer calculation, for example, similarity, distance calculation to do something searching. It is very highly accurate searching, not on the text, on the surface of the keyword, and it's on the meaning, so-called semantic similarity. And here is a lot. We can also think about it as something like a logic engine, as you are done. We are using it to do something like a logic, not something auto-complete or embedding. But I tell you that test in, test out is a lot of general problem we think about all ChatGPT test in, test out. But for today, we are using a test in and write out to do some data analytic and data processing. Um, okay, here's the explanation on embedding. As a case that in the past we do also have something very similar. We just want to put the language or text into a model or some engine to return a number, a list of numbers. This is so-called a vector. And this is the simplified version in 2D. In the actual route, it is a very high dimension, say 200 something. It's a very high dimension vector. And then we can project the vector and calculate the distance to group the data according to the meaning. You can see the example here. The swimming pool, the bridge, and then about the bros, it is about something related to water. It will in the vector domain is grouped together. Um, Another side that other tests you input, you will get for example, is something about food and restaurant. It will also group together. With this kind of vector dimension mapping and the projection here, you can do something searching very interesting searching method or according to the meaning, not just the surface of the text keyword. Here is the something background about RAG is a very popular method to doing large language model. You will just like this diagram, you will send the data into the model, and then we project into the vector space to get the embedding, the first step. And then when we search the data bed, you will put the question and then put into the embedding model and look for the similar data, and then return the data back to the large language model and then compose the answer. This is the logic behind the scene. A lot of the brain search engine or box model. You just go to the database and then retrieve the data and then give you the answer, not just in the past you just got a list of links from Google, but now actually better say it is something very similar, but to extract the similar information and then let it compose together and give you a summary and an answer. And this is something called the recursive metering, or very popular RAG method to for to to solve the problem of LLM. One of the important problems is that many people say, oh, LLM is sometimes outdated. Actually, you build a model may be outdated as 1 year, a few months before. If you want to get the latest data, you will use this kind of method to get the latest data and latest answer. And okay, the challenge of the educator in Asia, and this part this is time to for let Marcus to continue as we will share about the project. Okay.
Right. So thank you, Mr. Wong. So I believe you all have just heard about ML and how confident data will help us. So that's a brief idea. And now I'm going to explain how it actually works in a real life situation. So hello again. I am Marcus. I'm a student in Liwei Li. Right. So the challenge as an educator in Asia or in Hong Kong in general, myself grew up in Hong Kong, and it was tough. I'm not sure where about other places in Asia. And secondary school, primary school, there's like tons of homeworks, like huge load of homeworks, right? So for myself, there's a period of time, there's a lot of homework, unlike it was in university, and was nearly impossible to submit all the homework. So could you imagine if one teacher assigned two homeworks for that subject and another teacher from another subject giving out two homeworks and a whole day of 8 classes, that'd be a 16 pound of papers. So imagine the teacher has to mark this pile of homework, yeah, from paper and maybe convert to computer. So they will have to spend a fair amount, if not an equal amount of time, to mark one individual student submissions. And this would create a crazy workload for them sitting at desk marking on correcting all the students of the same class or module, and became an office-based working job. And this is not ideal teaching, right? They've got a life too, and maybe they would like to rather spend the time on improving their skills, or maybe they would rather spend their time on creating a more fun and interactive class for students. So having a large amount of homework, not enough time to mark them, in turn, it became a less fun and poor educational experience for students as well as um, teachers, right? Yep. Next slide. Yep. So this is our solution. Is to utilize AI technology, employing technology such as Azure, OpenAI Surface, ChatGPT to assist with or automate grading tasks. This AI demonstrates consistent and reliable reasoning and processing capabilities, delivering impressive results in automatic assignment evaluation. Furthermore, you can analyze student responses, providing feedbacks to teachers so we understand on which area they need helping or enhancing and further enhancing their learning experience. So not only we could analyze the answers as well as assessing the performance. Right. So this is a screenshot from Visual Studio Code of a student submission. So far, we are testing on receiving and processing two types of assignments, which they could be either Word documents or PDF files. So this is all, so far, this is all written in Python. For Word docs, prior to the processing submitted work from students, we need to extract the text from it, from the submission. So what we use is we use a docs to text library to convert the Word doc, and then filter them into something called filter film, and we mark them as label them as answers, so we could process the work afterwards. So again, like I've just said, we are only testing on PDF and Word documents so far. So excuse me. Right. So situations wise, we're also aware that students like myself, we may and teachers might prefer PDF files instead of Word documents. So nothing could be changed, right? The whole idea of PDF. Right. So hence we also analyze PDF files. So what we use is again a library called Pi PDF2 library to do convert documents, and then again store it in PandaStream and label them as answers so we could process their work again. We'll then pass this to a OpenAI service to analyze and to evaluate the student's answer. We'll talk about the detailed explanation later on our slides on how we analyze the prompts and how we tune the OpenAI. So what we are looking here is the source code for opening, calling, getting the OpenAI. So once submission is detected, right? Let's say detected, right? So it's relatively simple coding. We simply open the Chopin AI and create a project in order to use a LLM individually, right? For each assignment submission. So if we look at the function now, from the function that's there, get JSON ChatGPT, we pass the prompt in, right? Then we open the portal, the Chopin AI portal, using the chat completion API. Yeah, we fill in the parameters for the ChatGPT. This codes can all be found on Microsoft. It's very comprehensive, very easy to generate. So you can see all the keys down, like the temperature, max tokens. Those are the parameters we set for the ChatGPT AI. Right. So again, this is the source code for checking the student's work after opening up the OpenAI. We import the converted documents from the previous function and see if they fit the requirements. We'll talk about the marking scheme on later on. So far, I can see from the function, we have the students, the documents, and then we call in, passing the marking scheme again. So if there is a submission and it fits uh, the criteria, let's say the marking scheme, it will go on processing the whole mask comments, whether they copy from others, a whole list of items, which we will talk about it on later slides. All right. So, right, we call for the marking scheme, right, to follow the student's answer and output the Excel spreadsheet. So again, this function call for marking scheme, and like you can see all the mask comments copy from internet. Those are the criteria with right, yeah. So what we need to tell the AI to is that we need to help it understand what the role is, because they will be assisting educators, teachers to mark a student's work, and they would need, so they have to write something out, they have to produce something, and that similar to what an educator would say or what a teacher would say. So it has to know the expected output format of writing. So how do we round up students and mark up the submission? We created a guideline for prompts for the OpenAI to follow using prompt engineering techniques. So the machine would go through. So basically, prompt engineering techniques that we break it down into steps. So the machine would go through step by step and generate an ideal feedback. And in this case, would be ideal teaching feedback. So we need to code a simple self-code for AI auto uh, marking, set up prompts, marking rubrics, etc., etc. So basically, we want the AI to act as a teacher, to give marks and stuff. So right, so this is probably the core content. This part is probably the most important part of this presentation, so bear with me, all right? as I've just mentioned, we need the AI to understand what the role is. Yeah. So we use ChatGPT, but it's not as simple as, oh, I've got a question. It's gonna answer and answer it. I've got a question. He's gonna answer it. That's it. It has a logical engine to follow our lead, what we put in, to analyze and provide feedback. So we need to be a bit more, we have to provide a bit more details in order to personalize it, and also because each student's submission will be different as well. So you can see from the slide, there's a lot of criteria for each aspect, and each aspect is the question we ask the students. So why we have this many questions? So normally, when a student from VTC, where we from, where I'm studying, once they completed their internship, we from a real life workplace, we will ask this set of questions. They will answer it based on what the job is, and like the workplace experience, what they have learned, how they evaluate their own performance, and how does their I don't know the supervisor evaluate them, what the future path is, what they think about, what they can go in later on. So we have to try to be as detailed as possible here. Then we feed all this to ChatGPT in order to personalize it individually, so the feedback will be more suitable and feasible. So ChatGPT will understand when a student submits the documents, what the answers are referring to the question, right? Because if we just chuck in a lot of answers without criteria and questions, they wouldn't know how to answer it, right? So this is the prompt design for marking scheme, right? So you can see the rubric, the marking rubric. There are uh, 7 questions, so each question is worth 10 marks, so a total will get 70 marks. So we've got, like I said, we've got the job responsibility, the workplace experience, what they've learned, comments on the workplace or suggestion from supervisor, job evaluation, career path, what they think with the goal from this, and the formats if they wrote in correct formats like how many words or how many pages, that sort of things, right? So right now we're using the word counts, right? And and we got the bottom two, copy from internet and generative AI. So these two we've got a scale from 0 to 1 because we want to detect whether the students copy from another website or regenerate from AI, or maybe they copy from each other. It's hard to tell given a mark, so we have a 0.1 to measure how likely they copy the answer from elsewhere, right? So comment sections, as I've just mentioned, um, comments are like very special, like comments on the YouTube or comments from of another person. There's no fixed answer or anticipated text. A question would be like, "What your job is?" and I tell you my job is, but a comment is different. It's a freestyle writing, yeah. So we employ prompt engineering techniques here. We prompt the AI as much as we can of what the expected output is based on, uh, let's say, 4 criteria, because the fifth one is basically a formatting rule. So the 4 criteria we have is we have to explain the mark calculation comments. We show the mark for each rule, and the feedback for the comments has to be in encouraging style, yeah, and less than 200 words, so easier for AI to follow and less likely to cause any problems in the generated output. So this comments underlies a technical change of thought prompting. Is an approach that encourage LLMs to break down complex thoughts, since comments is a complicated freestyle writing. So we need to break down in step by step by providing a few demonstrations for LLM to learn. Right. So and in the end, at the bottom, you can see there is a JSON format. So formatting rule on what we want the AI to generate out. We want JSON format and replies in JSON because it is smart enough to follow our instinction to convert the result into JSON format. So when it is JSON format, it can be passed back to Python, then read it back to data space for further analyze. Yeah. Right. So this pretty straightforward. So when there is instructions, there'll be also a region or specula of possible errors, right? So we highly recommend referring to Microsoft Learning's prompt engineering technique because they are effective in addressing a whole lot of issues. So, however, we could still find these findings as references because you never know when something could go wrong. So occasionally, in the red lines there, ChatGPT could return invalid JSON by disregarding the instruction to not including anything after JSON format, so we have nothing to analyze. So this is referring to the settings in the first function when we call for the OpenAI, and it could malfunction. To address the issue, retry mechanism would be used. So we would tune the temperature to 0.9. So let me just so example here is that a high temperature could result in fancy delivered word choice, but less coherent, so less sticking to what the question to ask. Likewise, penalty refers to how repetitive the feedback or the words show up in the output. Right. Right. So this is a basic outputs from two different students. Right. So these are the feedbacks for students that score 84 marks. So we got um, the AI is telling the students, "Oh, great job! Your answer is well structured and clearly showcase blah 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 blah." And in the end, it provide a comprehensive a positive and encouraging comments for the students. And on a contrast, if you look at 48 marks, you can see a feedback is still provided to them equally. So this is a well-written reflective journal that showcases blah, 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 blah. And then again, a positive encouraging comments for this freestyle writing. So overall, the student has shown a positive attitude toward the career path. So this slide is just demonstrating how the AI is able to give different feedbacks in encouraging style to two distinctive markings of student submission. So as we have just mentioned, we would try to detect similar works, whether works are copied from the internet or generated from another AI. We need to use Azure OpenAI embedding. So the techniques Mr. Wong have just mentioned in the beginning of the presentation. So aside from detecting works that copy from other students, with this method could also detect distinctive work, so work that stand out from the rest that did not copy or just wrote it very differently, or someone that didn't write anything at all, right? So we could use embedding to calculate similarities in answers. We embed the answer into a factor point. So factor point is like it's like GPS. If you the dots here and the dots there to calculate the distance between two dots, the closer the dots are, meaning the more similar they are, because embedding is a special format of simple data representation. So yeah, in this case, for each embedding is a factor of floating points, such that the distance between the two embedding in the floating point is correlated when there is a semantic similarity. So semantic similarity means they have written in a very similar style of English sentences or whatever sentence they are written in. So if two texts are similar, their factor representation points, the floating points would also be similar and closer as well. So how do we do it, right? So this is a function. This is the it's not a function, just a cluster of codes. We group this data into 7 different groups because there's 70 students. We group them 10 per each groups, right? So this is called clustering technique called K-means clustering. So K-mean clustering is a methodology to group them into smaller groups, hence clusters there, because one dot represents 10 people, so be a cluster here, cluster there. So clusters of groups, cluster of circle, and we calculate the similarity of these circles based on the distance. So again, we're talking about factor points A, factor points B, and now these points actually represent a group of people. So how similar this group of people to this group of people. So yeah, right. It's a Python library again to visualize the results. They have built-in model for plotting different graphs. Um, yeah. Oh yeah, sorry. Go back last slide. Sorry. Yep. So I mentioned, so to use this technique, we used embedded ADA v2 as ADA version 2 model to find out if students copy from each other. Yeah. So as much as we discourage students from aiding themselves and copying from ChatGPT, we don't want them to simply copy and paste from each other. So we need to analyze the similarity. Right. Right. Yeah. Cool. Next slide. Yeah. So this is source code for comparing the clusters and highlighting the results. So we use the T-distributed stochastic neighbor embedding. So in short term, it's TSNE. So TSNE is a tool for visualizing high-dimensional data. So like the slide on the next slide is a graph. So it basically plots similarities between data points to join and try to minimize divergence between the join probabilities. A lot of technical terms. So this graph, as I've just said, 1, 2, 3, 4, 5, 6, 7. So the 7 crosses are the dots. We sample the 70 students into 7 crosses. So you can see each crosses is representing a large group of students. It's a scatter chart illustrating the 7 groups as shown here as crosses. So you can see how similar they are on the chart. And this chart using a TSNE, sorry. Right. Now, 2D diagrams or charts or graphs are great, but it is getting boring nowadays, yeah? So therefore, we implemented the principal component and analysis, another technical term, PCA, for visualizing, embedding, and clustering results. So it is to project, how to say, right, singular value decomposition of data to project it in a lower dimensional space, right? So in simpler terms, 3D graphs, right? Great. So this is the graph on explained variance ratio over a number of components per clusters. So if I remember correctly, so nothing's wrong with this exponential rate of linear shape. So in general, it should look like this because the more differences in answers, the higher the variance. So as the number of components and the more cluster of students or groups are added along the way, the higher the variance is. So this perfectly explains the relationship. It'll be weird if there's a straight line, there's no variance in the number of components, meaning all the students may have copied from one or another. So it'll be a straight line flat. Yeah. Right. So again, this is source code for 3D graphs. We plot this onto a 3D graph after checking if the statistics is correct. So we shown from the last slide, line is going great. So this baffles me as first. It's very intriguing. So let me briefly describe what we're seeing here. Remember, there were 70 students, and each student has a color dot. Um, so each color dot representing a group of 10 people, right? So if you can see names, great, they stand out. They didn't copy from each other, or maybe like Mr. Watt told me, they didn't put in anything in the document as well. But if you don't see the name, meaning they're overlapping another students, indicating there's a high chance they copy from each other or they copy it from another website or AI. So you can see there a bit of cluster situation there, a bit of copying but again, it's a um, feedback piece of work. So you write down comments. Maybe they wrote similar terms in comments. You never know. But overall, this is they have a similar factor points, meaning they have similar writing style, right? If I dare to say, right. So this is a demo. It follows the essays in Microsoft Word and Adobe PDF formats from Model LMS. This is a YouTube video made by Mr. Wong himself on the YouTube. If you are interested. So this approach again involves creating students assignments submitting in Word and Adobe PDF, where students provide an easy and about essay about the internship to streamline the process. Is essential to the accepted file types within the learning management system. Right. So in the end, I think a bit too early on the time. Right. So so if you are a quick learner and you are familiar with the system, you could down your exhausting marking period. Remember the anecdote for myself when I have 16 part of homeworks, teachers will spend all day marking 16 homeworks from each student or so, right? So that could take hours. And now Mr. Wong have tried himself. He regraded 7 students from long essay assignments in Microsoft Word in 10 minutes for less than US dollars, less of a five cents, right? 50 cents. So in this presentation, we told you about how it's more ideal for teaching environment for both students and teachers if they use OpenAI to help them, right? It is less time consuming and teachers can mark assignments in a much faster pace in AI and spend their time rather on teaching and on the more important tasks to enhance teaching. So as well as informing you guys about um, utilizing embeddings, the clustering groups, filtering into smaller groups and such, and plotting into graphs and 3D graphs, right? We're able to tell or gain valuable insights into students' answer, which allow us to understand better on their thought process or knowledge levels and areas that may require additional support instruction, like pretty straightforward, like understanding if they copy from each other, why do they do it? That sort of thing, right? Mental support. Now we're emphasizing on this. So students are more. So in turn, we're hoping that not only teachers will understand how to use AI efficiently, and students are more responsible using AI and coping with their coping AI with their realities. And teachers or educators do not have to feel outraged by students, like the quotes from Mr. Wong earlier. AI will not replace us, but a person that know how to use AI replace you certainly on a skill spectrum. Yeah. So in conclusion, help us graded 70 students long essay assignments in less than 10 minutes. It's a well spent hours on Python to save thousands of hours in future. And again, by utilizing embeddings, we're able to gain valuable insights on students' answers. Right. I believe that would be it. I think we
Okay.
started that
Yeah.
early. Oh,
It's fine.
and
Yeah, we can answer some questions here,
yeah,
and today our presentation is completed here and finished. And please feel free to ask any question. We will stay here for a moment.
yeah,
Okay.
yeah. Any questions? We're we're still
Please
here.
feel free to ask. That it's okay.
Yeah, yeah. Maybe a little bit early, right?
It's okay, Mon. That's fine.
Yeah, yeah.
Mm, no problem. It's just wait for a moment. If
We'll
there's
just
no
wait a
question,
while. Yeah,
we may finish here and see if um how about the host. Okay. Yeah, I think since there's no more question, and feel free to reach to contact us if with the social media, and we just finish the talk and And presentation here. If okay. Any
Oh, there's a
question?
question.
Is
Uh,
it?
any suggestion or comment on the embedding model?
Yeah. First of all, we tried some different random one, but we do test on the hacking phrase and also
Mhm.
the OpenAI ADA one. Um, for the performance is depend on the language your student answer. If just something just purely on English, we found that the performance in general, both of the model is very similar. It's not very large differences. But if you do something like us, we will some student answer will combine some Chinese and English together. It will have difference. And at this moment, we found uh, the OpenAI one, the ADA is okay for multi-language. But if you're using some open source model, not about Llama. Llama is large, it's very large one. We use some smaller model ones if you want to speed up the embedding process. It will have some different performance on the output. However, since the everything's under the large language model output is something statistically you do something on statistics. Statistics is fine to have some certain amount of error. You still will be able to help you to complete your process. But in general, you will feel the commercial one or the more popular one is to have some differences from our experience. And for vector database, it depends. We try the Google one, but the Google one is really uh, you will take a lot of time for you to build the mode to start the engine or something. It's too heavy, and we just other truth is that we just use a very simple crawler. It's good enough for us to for many use case or Pincon is much faster. It depends on your data size. If you got a lot of data, the large number of data, you may need to use some car render run or commercial or service API service level one, what are they be. But for the case of our assignment situation, we had just have a few hundred students, and then the question is run by run. We will not combine all the question together, put into single database. Actually, logically, you can think about every question is one per question per database, and the number of data is not large, and then we can use the just the open source one, just the Chroma will be very good performance for our case, and even if the data size low, is small, you can directly use the traditional method, just loop it and then calculate all the pair of the distance. Don't use some estimation method. It's still okay as the number of data. It depends on how many vector you have. You have so a few hundred vector. You just brute force attack to calculate all the actual distance between the answer. But for the large number of cases, we will use a database because they are some algorithm so-called ANN needed labor. It will help you to give you the estimated answer and then very quickly without a lot of calculation. So the it for our application, even though we don't use database, will be fine.
Right. So I've just written up a summary of what Mr. Wong just said, and I'll reply you as well. A new question.
Uh,
For currently we're using Azure
oh
AI
no.
search.
Yeah. We don't use this. It's too expensive. Believe in me, that it's just we just the problem domain is dependent. If you use the searching is when we use the Azure search, if you got a lot of large amount of data and also you got some image, you got a lot of document, you are better just using the search service. But for our case, it's just something the problem domain the number of data is dependent on data. The data size is not very large. It is not worth for the not worth to use the search surfaces in different calendar there's no cheap version in in Azure actually. But for other calendar those as maybe BigQuery in Google, is certainly cheaper to store the data and then use BigQuery to query. But for the case that is Azure, there is no cheaper solution at this moment. Yeah. Okay, that is
Right.
this.
So I've written the answer for you, Anthony. So let's just for you to recap. Obviously, I didn't capture everything, but this is summary of
Yeah,
what Mr. Wong said. Yeah.
it's
Yeah.
because of the money problems. To be honest, our
Yeah.
solution is very cheap, and we have the most expensive one is ChatGPT one, but you have to pay. We found that we use other open source model, for example, Llama. The performance is not really compatible with ChatGPT 3.5. Yeah. Furthermore, from
How much factor more?
I'm not very understand your question about the factor. What mean or is it's a factor? Can you give us about the money?
Oh,
Yeah,
the
yeah, yeah.
range.
Yeah,
Yeah.
it's just we use the money mainly on the not about the track. Since you know the course here is the embedding one, and also the every student answer we will say 100 student we will call track GPT for 100 time at least. Okay, at least. Why I so call at least? As the case that's when you know that we try to
Mm,
ask track GPT to return a JSON for us, and but in some case this is you know that LLM will not always follow your instruction. Sometimes
mm, mm,
it will just return something not JSON for you. If you receive something uh not the valid format JSON, it will you our solution is quite straightforward. Just retry. There's a reason why the course on the track GPT 3.5 may be more than the number of students, say 20% or 10%. But we try other model. Okay, we try other random model, even worse. Okay, ChatGPT already uh quite follow your instruction for. If you're using ChatGPT 4, it will sometimes follow always nearly always follow instruction from you. So, for example, you ask it to return JSON for you, it will always return JSON. But for 3.5, will not be always. The course is based on this estimation is number of core here, and I think I put more than I forget the calculation here, but so mainly the cost is on the embedding and the ChatGPT. We repeat and repeat, and one is very cheap. Just the estimate amount is $half, half buck in US dollar per
mm,
hour cost. Say 100 student for an assignment. Number of question also depend on the price. Okay, as you know, every question I will do the embedding. Every question I will per student I will do the I need to call ChatGPT. So the cost here is a estimation, but it depend
mm.
on your assignment, number of question, and number of question it mean number of answer and number of time you need to ask ChatGPT. Yeah. So I can't tell you the exact number here. I forget it. But the estimation is about half US dollar in general.
Okay.
But
That's
this
quite
is
low.
worth to do it. Believe in me. I your my hourly salary is very expensive. If I mark an assignment for 4 hours, it is really not worth anymore. Now my process is that I will mark my all of my student answer. We use AI, and then I just review the answer. Maybe review the mark sheet to take some sampling and check it. And this is the way I'm doing now.
Right.
Mm, yeah, but
Yeah.
170 student in validation problem
Yeah.
is the is
Playing
it, yeah
problem.
yeah
Yeah.
yeah this is the case that is this is the difference is between language model. This is very different from the old one and the latest one. The latest one, I think more of the render they certainly to train the large language model to return you a validation in the latest version. Yeah, this is the from the beginning to the end to the current situation. What I feel is very different. Well, at the beginning, I using this system is always not returning JSON for me, but now after a half year, or even though we don't train the source code and don't train any source code, we run it. We will find the number of core is reduced since there is no more. The number of exception on invalid JSON is less than before. Okay, any more question? If there's no question, I think we may stop here today for today. Hello. Yeah.
Yeah.
Okay.
Yeah, I think there is no more questions.
Yeah, it's good one. It's thank you.
Okay.
Okay.
Um,
Thank you.
Thank you, Marcus and Wong, for joining us for the session. Really appreciate that you guys are taking the time to share the knowledge with everybody here. Really do. And yeah, and thank you everyone for joining with us as well. And make sure you check out the links and everything that so far we had discussed in the session. And we'll also have the recording pretty soon uploaded. And yeah, hope all everybody here is already in the community.
Mm. Okay,
Thank you
see you guys.
again, and
Thank
Yeah.
you for the opportunity.
Like,
Thank you.
bye bye.
Bye.
Yeah.